So applications. Okay, so the first one, a company can produce digital alarm clocks at a cost of $8 and fixed costs are $45. So on our actual exam, I would give you the function, okay? So this one didn't, but so I got these off of last year's exam, and I made them make the equations last year, not this time. So I would give you the equation. So this would be 8x plus 45. So you can write that function right on your sheet. So it would say cost function 8x plus 45. So part A, you would not need to know how to do. I would give you the cost function. B, so what's the marginal cost function? The derivative. So derivative is just 8. And sometimes I would ask what this represents as for a mark. So if on the test it says, and what does it mean? Then that's worth a whole point. Okay? So what does this mean? It is the cost to produce one additional item, or the next item. The cost to produce one more item, or the next item, right? Or the x plus 1 item, whatever, however you want to say it, but it's the cost to produce one, the next item. C, the average cost function. So the average cost function, we put a bar on top to be average. And how do we actually do the average function? Do you remember? It's divided by x. So that's your average cost function. And what does this give us? The average cost to produce one item at the production level that you plug in. So usually a company has a certain production level, they make 1,000, and if you plugged in 1,000, it would be the average cost for each item when they make 1,000. Right? D. It's a test in words. It doesn't mean a whole lot, but the average, this says the marginal average cost function. So what's that saying to do? Derivative of the average. So how would we do that? That would be quotient rule. So low, D high, minus high, D low, 1, all over low squared. Now on the test, when I get you to do something like this, I ask you to simplify it. So let's simplify it. So this would be 8x minus 45. So far, so good. So part E says evaluate each function at 30 and say what they mean. So E. So we want the cost at 30, the marginal cost at 30, the average cost at 30, and the marginal average cost at 30. So let's figure out these numbers. Second one, there's nowhere to plug it in, it's just 8. At every production level, it's 8. All right, so what do these numbers all mean? So the cost function at 30, what does that give us? What's the 285? This is the total cost to produce 30 items. That's the total cost. The marginal cost is an approximate cost to produce what? The 31st item, the next item. Or it would be like a increase in $8 to the total cost. That's the other way you could think of it. The total cost would go up by 8. The next item, what would the average cost being 9.5 mean? $9.50 is the average cost per item if 30 items are made. So basically, it's taking the total cost and dividing it by 30. So it's like how much of the 285 is divided up if you just divide it up evenly. And what would the last one be? So the derivative is either you can think of it as the average cost for the next item, but it's kind of negative. So the other way you can think of it as a derivative is a rate of change. So it's the change that happens for the next item. So what would this be, do you think? So if we made another item, the average cost would decrease by 50 cents. Oh, 5 cents, sorry. Do you see it? So a negative derivative can be a decrease. It doesn't mean that the cost is negative or we're losing money. It just means the average cost would be, instead of $9.50, it would go down to $9.45, right, if we made one more item. Okay, so this is saying that the average cost decreases by 5 cents if we produce 31 items or one more item. So adding an item will decrease the average cost by 5 cents. And I didn't put a list of derivatives on this practice, but on the actual test there's a list of derivatives. It's just that we're doing derivatives all through, so I didn't put it as a separate one here. But on the actual final exam, the first section is just a list of derivatives. It says find the derivative and do not simplify. Okay. So quotient rule, product rule, chain rule. So practice a list of derivatives. 2. You could go back and practice your first test. Okay, number 2. The manager of an electronics store estimates that the number of flash drives that they will sell at a price of X dollars is. So what is this? The S is the number of flash drives or items, and X is the price in dollars. So you don't need to write that down as part of your answer, but I always write it down, and the reason I write it down is to get the idea of what it means in my head, so that when I answer a question, I can say what that number represents. So find the rate of change of this quantity when the price is $6 per flash drive and interpret your answer. So what are they asking us to do? The derivative. Right? Rate of change means derivative. All right, so how do we do the derivative of this? So the question when you're doing a derivative is, do you rewrite this first, or do you just jump right into the derivative? So is it a quotient rule? No. It's not a quotient rule. Why not? No x on top. So when there's no x on top, but there are x's on the bottom, you have to bring the bottom up to the top. So you would rewrite this first. 2250 is already on top. You bring the whole bottom up, and it becomes a -1. You don't just bring part of it up. You bring the whole thing up. Sometimes it would already be in a bracket, but that would be too easy. So not a bracket, you make sure you bring the whole thing up and put a -1 around it. And then this is the chain rule. So the derivative. So a bracket to a power, you bring the negative down front, rewrite the bracket, 4 steps. Subtract 1 from the exponent, times derivative of the inside of the bracket. Power down front, rewrite the bracket, subtract 1 from the exponent, times derivative of the inside of the bracket. So anytime you've got a bracket to a power, that's what you would do. Okay, so there's our derivative, and then what does it say? Find the rate of change of this quantity when the price is $6. So is the price the S or the X? X. So they want us to plug in X is 6. So I should have maybe fixed that up. That would be 15 squared. All right, if you brought that down to the bottom, x plus 9, if I had simplified that first, which I probably should have done, and then plug your number in. Okay, so what do we get? -10. All right, now it wants us to, so we can do all of that, but part of the question is, what does this mean? So remember, S was the number of flash drives, so it's the number of flash drives decrease because it's negative. Yeah. So is it $10? Is it 10 flash drives? What is that? So this is, so remember a derivative is the S over the X. It's the change in the function over the S. This is the number of flash drives. And this is the price. So sometimes you can read this off and say the number per dollar, right? Remember, this is for if we increased it by $1, what happens? The number of flash drives goes down by 10. So the number of flash drives decrease by 10 if we were to increase the price to $7. So this is the number of flash drives that we would sell. So if we increase it, it goes down by 10. So you'd sell less by increasing it by $1. And different prices would have different results. Okay. Does that make sense? So the actual answer would be part of your marks, but I would be looking for, if I said to interpret your results, that's a point, right? So try. Even if you get it wrong, you've tried and it might make sense. But I always think your derivative is if you add one more, then it either increases or decreases by that much. Right? So we're adding one more x. X this time is price. And the number of drives, that's the S, either increases or decreases. 3. Boxed-in moving company calculates that its revenue function is where R is the revenue in dollars, and X is the number of trucks. Find the number of trucks that they should use to maximize the revenue and find maximum revenue. So how do we maximize something? Yeah, right. So to maximize, we take the derivative and set it equal to 0 and solve for x. Right, so what is our derivative? Derivative of 240x is 240. Derivative of minus 3x squared, bring the 2 down front, so minus 6x. Set that equal to 0. Okay, so that's 40 trucks, because X is the number of trucks, and it says to maximize the revenue and also the actual revenue. So what would we do with the 40? How do we find the revenue? Put it into the function. Right, into the original function. So R of 40 is 240x minus 240 times 40. Minus 3 times 40 squared. Now, what if I asked you to show that that is, in fact, a maximum? Yeah, what do we do to show that that's a maximum? We can use the second derivative test, which says what? Take the second derivative, just minus 6, and if that's less than 0, then that means it's a parabola this way, and it's a maximum. So that's what the second derivative test tells us. So the second derivative, if the second derivative is negative, it's saying that the function, or the number you just found was at the top of a hill. So that's called the second derivative test. Second derivative is less than 0, then it's a maximum. If the second derivative is greater than 0, it's a minimum. Sort of the opposite of what you think. But the second derivative is talking about the shape of the graph, not whether the number is small or big. It's talking about the shape. Okay, and number 4. So the population of the world X years after the year 2010 is predicted to be, this is the population, 6.9 e to the 0.00743x billion people, for x is between 0 and 30. So p is in billion, and x is the year. Okay, so what's the question say? Use this formula to predict the world population in the year 2030, and then what is the rate of change of the world population in 2030? So 2030 would be what x value? 20 years later, yep. And so they want the actual population at 20. Make sure you put that whole exponent in a bracket, or get that number first. So I get 8.0054400809. I'm writing the whole thing down because it's in billions of people. Right? How many zeros in a billion? 9. So this would be 1, 2, 3, 4, 5, 6, 7, 8. Yeah, so this would actually be 8, 1, 2, 3, 4, 5, 6, 7, 8. Right? So you could round it off to 8, that would be fine, but you're actually, if you rounded it off to 8, you're actually missing 5 million people. Do you see that? So I just kept all the digits on my screen because I knew it was in billions that I'd have to move that decimal over that many, so right. I don't know. Saying approximately 8 billion, is that the same as 8 billion and 5 million more? I don't know. It depends whose scale you're looking at, but that's a lot of extra people. Okay, and then it says the rate of change of the world population. So we need the derivative. Okay, so here's our function. So 6.9 is a constant. Derivative of an e, you rewrite the e, times derivative of the exponent I just multiplied the 6.9 and that decimal. You wouldn't need to. It's asking for us to plug in 20. So according to this this model, and so I move the decimal over 9 times per billion. So this is saying that the change in population would be 59 million in the year after, or in 2031, or by the year 2031, because that population actually grows within that year. But by the time it hits 2031, it's predicting that there would be that many more people than there were in 2030. And the only type of word problem really that's not on there is if I give you the derivative and ask you to find the function. So that would be the initial value type, right? If I said, you know, the marginal profit is this, find the profit function, or the marginal cost is this, find, so you'd take the integral. Okay, so our time is sort of up. Let's just do one of each of the other two, just to remember what they are, and then, so let's say the absolute max min. It says here and local. You don't really need to know local, but what local was is just saying, is it a hill or a valley, or is it an endpoint? So it really is, it's nothing extra, but I'm just going to ask for your max, like what is the maximum, that type of thing. Okay, so question 1. So if you remember when we did these, so the difference here, it's just like finding the maximum revenue. We take the derivative, we set it equal to 0. The only difference here is that the maximum, these are not just parabolas, so they could be at an endpoint, like it might not just be a parabola like the revenue was. So we still take the derivative and set it equal to 0. So our derivative is 3x squared minus 4x. We set that equal to 0. How do we solve that? What factors out? An x. And then the 0 property says once you factor that x equals 0 or 3x minus 4 equals 0. So these two numbers were called our critical numbers. Okay, they were called the critical numbers. Now what did we do once we got the critical numbers? And these are our endpoints on our interval. So the maximum and the minimum is found at either a critical number or an endpoint. So we made a table of values, and you put your endpoints, whoops, 2, -1. Now, what about these? What do we have to look for before we put them into our table? Right, they have to be between these two numbers. So is 0 between -1 and 2? Yeah. And is 4 over 3? That's 1.3. Is 1.3 in there? Yes. Okay, but you want to check that the critical numbers are in the interval. Right? And then once we fill it in, what do we get? I shouldn't, oh yeah, -1. Zero. Okay, so we get our numbers, and then what do we do? If we want the minimum, it's the smallest. And the max is the biggest. What's our biggest number here? 0. And you can have a tie. It just means there's two equal heights. So both of these are max at x equals 2 and x equals 0. So you can have a tie for that. Okay, so my question is, since we're not done but class is over and there's another class coming in, do we want to finish this sheet on Thursday? Like, is anyone going to come if I show up to?
Is that possible to write down a note and
like just to do the solutions and post them?
Yes.
Yeah, I could do that. Yeah. Yeah. Yep. Okay. So that's what I'll do. I'll finish these sheets and post them just in the notes, so they'll be there. Okay. The recordings from everything I did will be up, and I will not show up Thursday then. All right, but the math help is open, and I'm here. I can help you anytime. I'm usually here during the day, though. So email me or text me if you need help. And otherwise, I will see you either Wednesday or Thursday in this room at 7 next week.